I haven't been doing any plugin or toolkit coding for many months now, as you can see here, because I've been working on more music than plugin coding. So I just got some impulse idea to just jump into it and see what I remember, what the current state is, and that kind of stuff. So I don't remember much myself actually, so we'll just see how it all turns out. I just thought I could just look into it, talk a bit nonsense about it, maybe the plans, maybe the ideas, and see where we will end up. So I don't guess I don't have this copy the let's just copy the compile the demo first. Just see if it actually works. Compile again. This is a simple compile script. You don't need any make files as usual. That I remember that part. We don't need any make files, CMake, build systems, complicated setup, lots of dependencies, and anything like that. You just copy the entire toolkit from the repository and just compile it. So now we compile an executable. It's that /f or -f, I think it's called in English. We call it -f. Exe means standalone executable, and this means we have an executable. Oh, so this is how it all looks. It still works really nice, smooth and nice. As you can see, the problem of scaling stuff, everything scales really nicely. We have a bunch of widgets and timers and what's this called? It's called what's it called? It's this I don't remember anymore. Anyway, we have all this going on at the same time. Everything is nicely, and we have bitmaps and PNGs and SVGs, and we have a bunch of widgets, and we have parameters and everything. As before, everything still works, of course. Nothing has changed. And another interesting thing. Let me look into it. I still need to look into the. Let me just see. Optimization, if it's still as optimized. I just want to refresh my memory. So this is very interesting in my eyes, but I guess people nowadays don't care much about optimization stuff, unfortunately. 2 megabytes, that's in, and it doesn't need anything else. That is really nice. And see, no CPU use, almost not whatsoever. But let's go back to the coding stuff. I don't remember everything myself, so let's see if there's something interesting. Let me see. This is the actually there's one still interesting part is a plugin is just one CPP or C++ file. This is just my build system. As you can see, it includes a C directly, ugly and as F, but it works very well. Some may be horrified by this, but who cares? They can do the abstract academic stuff themselves and get hooked up, or what should I call it? Struggle with build systems and everything. We don't need anything of that. Interestingly, let's compile it a plugin instead, just to see if it actually works. Still works as we. So we have this synth. We can compile synth here, and we want to compile as a clap file. Clap plugin, I mean. We could also compile as a VC3, VC2, and let me see if I'm not really sure if all these plugins formats LV2, VC2, VC3, LADSPA, DSSI. I'm not sure which of them is still working, because at the moment I've decided I will only publish or post clap plugins myself. Now I have a clap plugin, and I have already set my why is it on? Oh, of course we need to have a clap there, but of course we can just rename this, because if I'm not completely wrong now, this is a clap file with a wrong, yes it is, with a wrong file name, so you can just rename it to clap and just go into our Bitwig or any other host supporting clap, Reaper or whatnot. Oh, no big previews, please. And here it is. Let's try it out. Is it not working? Or did I do something wrong? Let me see. Maybe I didn't drag it properly. Oh, here it is. So it still works real nicely, and you can see this zooming works and is proportional in Bitwig is doing some timer related real naming stuff, so you can see it's much more what's it called in what's it called, jerky in Bitwig, but if we compile as an executable, it's much more smoother. Let us see. No, and just compile as a debug version because it takes a lot less time. And here's the standalone version. You see the smoothness of it, and this is still just debug. Still a oh, it jumps a little bit. Oh, it's been a while since I looked into this. I have to maybe it's because my computer is not struggling but working a little bit now because of this. I still have it running here. Let's see if it actually makes some sound. Yes, it still works. And by the way, I added a few things to this one, but let's not go into that part. I can feed resonators with audio input and stuff, and I could filter it smooth. But let's not go into that part yet. It still works. Okay, that's nice. We can compile clap and standalone, no problems. Let me see, what else have I forgotten about? Let's just look into it. The GUI stuff is maybe probably a bit into. Let me see what this clap version is. Oh, I support just 1.2.1 at the moment. I know there's been 1.2.4 or 5 is being released. Just some minor, not minor, but documentation changes, updates, and a few extensions like some graph and gain reduction indicator stuff. But I will add them in when I get back to coding. But at the moment, I'm just refreshing my memory. Interesting with the GUI is it actually made quite different from other Linux GUIs. I think because, especially on the clap Discord, they talk a lot about the typical Linux stuff for doing this. What is it called? It's called the POSIX FD support or file descriptor thing for GUIs, which I'm not using at all. And also this timer stuff, they are kind of the host supports a kind of extensions for the. Let me see if I can find it. Go into the plugin clap extensions. No, it's empty. I thought about moving all extension support into a separate file, but I haven't done it at the moment. So it's still in the clap GUI. This what is it called? This POSIX FD support. I'm not using that at all, and I'm also not using this timer support, which I've seen all the other Linux GUIs are using. So I can't. Honestly, I have no idea why they think that is necessary. I haven't done that in 15, 20 years. I don't know if it's 20. Yes, probably almost 20 years of Linux coding and all the plugins for at least 15 years. I never ever used it. So I have no idea why this should be necessary. The easy way to do it is just to, let's say, to GUI here. It is the X11 windowing system. X11 window. Because you can just, as I'm doing here, let's see, you just open display, separate display for every plugin and handle everything yourself. I have no idea. And the embedding, let's say, embed, no result. Why is it not finding anything? Okay, it's of course it's in the clap part because the GUI itself is completely standalone. It's not related to clap at all. There is absolutely, let me see, there's absolutely no clap. There's no clap results at thing in the GUI at all. It's completely separate. That's why it also works as standalone. And it all hosts also in Excel, in clap and VC2, VC3 and everything, because there's no, you don't need any support from the host actually. I'm just opening my own the connection to the X server and handles everything myself and just embed it into the GUI hosts window, provided window, if you have an embedded window. If not, you're using the remote window part. Here I see I have separated here in the editor. I have this embedded editor and then I have the remote editor. The embedded editor is here. It is embed. No results of what's it called? Okay, I had probably called something else. I tried to abstract things. Maybe that was not a good idea. Let's see. Oh, this is just handling the clap API because my GUI API is directly mirroring the clap API, even for a VC2 and VC3. So I'm the GUI editor here. Editor is just a implementation almost like all the clap stuff. So in where do I actually embed it? Plugin here. Embed. Oh, okay, maybe this. Let me see if I can find it. Some setup editor. Okay, I have it sorted by. Let's see if embedded it will create window. Let's see. The next level is embedded editor, of course. Let me see if we can find anything. We don't find anything. Is it open? I think maybe. The parameter from okay. This. Let me see. No, I don't remember where everything is actually. Let's see. Plugin maybe. Editor. This is the editor. Link pointed to embedded to become embedded if you have an embedded editor. Init editor parameter. This is for setting up the when you open editor, you want all the parameters to be the correct values. So this is just going through them all and sending them over to the editor. Same editor size. Let me see, because the editor is created, the size of the editor is given to you before you open the editor. But in X11, it wants to know the size of the plugin, the editor, when you create the window. So I just just save it here and wait for the set parent. Okay, it's parent. Set parent. Here I open it. Editor set parent. If you go into that part, here is it. Is reparenting. This is a reparenting stuff. Let me see. As you can see, I just call the reparent window. I don't use this file, the script or nonsense stuff. I just reparent it. I just create a separate connection and then just reparent, and everything just works. Which means I have full control. And the only difference between an embedded editor and a remote editor is the same as a floating window or GUI in clap, for example, or maybe it could be this in VST3. There could be this separation of plugin and editor. So then we could handle our own editor in whatever machine we are running on and have some kind of connection between them in some kind of communication, and then do this on every side, because the window is completely separate. But enough of that. That was just me babbling about editor. Let me see if there's any interesting things. I don't remember, so let me refresh my memory to see what's actually happening here. Because this is the only CPP file we are using, we're not linking in anything else actually at all. Everything is included already. We just need to include the header files for whatever we're using. We're using everything related to a plugin, which drags in a lot of other stuff. We need node ports, parameters, plugin base, etc., etc. Same thing with we need also a processor, because we are splitting the plugin in 3-4 parts. We have let me see here. I separated by these kind of separators. We have this descriptor, which is needed before the plugin is created. The clap is or other formats too, I guess. Goes through all your plugin files and then do some investigation. And in clap, you can just read out via some factory stuff. All this info, so I've decided not to abstract the plugin descriptor directly, because the entire toolkit is clap based. So in the bottom there is a clap file, no matter what, no matter if matter. If you're creating a VST plugin or LV2 plugin and whatnot, you're always a clap file at the bottom. And then there's this layer on top, like a wrapper pattern, which is using that clap. It's actually, all these wrappers are actually minimal clap hosts. It hosts this internal plugin, but present it outwards as a different kind of translates the API calls between VC2, VC3, LV2, DSSI, LUDSPA, or standalone executable. That's how it works internally. So I decided not to kind of hide away the clap descriptor. Like we could have, of course, have some internal stuff, but then we have to have needlessly had another layer on top to hide it, and I didn't feel like hide it just for because of hiding it, so it's still a clap descriptor. We need a processor. A processor, actually, I decided to do that kind of separation because of clap, because in clap, the process function takes or kind of manages both the events in and out and the audio processing. So a processor in this toolkit do all that kind of stuff. It handles events and handles audio in all both directions, and do all this buffering or queuing and all that kind of stuff, all this thread synchronization stuff needed to get this working. So that's the processor, and as you can see, in this case, it's very little. That's an entire processor in this campus. We just inherit from some ready-made class, like a voice processor, which is a bit. This is a bit, but it handles everything quite simply. I'd say some utilities, some init, activate, is target. Or this is just some helpers to kind of see if evens to voices, because this is a voice processor, is meant for a synth. And same thing is activate. Active is a voice is active and stuff. But here's the process audio. It's the entire function to process audio. And we have in a voice processor version, we have different processors. We have a block processor, we have an interleave processor, and we have a quantized processor. Sorry. And this voice processor. I'm thinking about splitting the voice processor into this threaded processor thing and a voice specific just for voices. So I could use, for example, multi-threading for example, if you could have, for example, you could split up the audio into 3-4 frequency bands, for example, like bass, mid, treble and stuff, and then send each of these to separate threads, and then combine them in the end. So you can have multi-threaded, multi-frequency or multi-spectral kind of stuff easily. So that was my idea, but currently you can actually use the voice processor, just have imaginary voices. But the voice processor is doing it a little bit different to do, because in this case, again, because I'm depending a little bit about this is a bit as you can tell, some if-defs here. Just splitting all the voices into separate threads, or not separate threads, but they are separate, completely separate. So each voice are calculated on its own. So each voice or potential voice has a event queue and a buffer to calculate from and to, or to, I mean. And of course I have access to the global stuff, but that's so that I go through this entire block here, split out the events into different queues, and then set up for audio processing. So that's the only thing the voice audio does, it kind of splits up. Let me see if I find something interesting what it's actually doing. It goes through all, what's the count? The count is, okay, this is the template voice thing. So it goes to all the potential voices and just turn something on and off. If they are released, they are, for example, if they are finished, they are kind of put into a available list and that kind of stuff. And after you're doing that part, we are going to everything that is waiting, playing, or this is some different states I have. I can have a voice can be waiting, which means it is created and kind of waiting to be processed, this, but it hasn't received any events, so it shouldn't do anything until the state is playing. Because, for example, because at the beginning of the block, I might set I'm not really creating, because there's no new and delete or something. There's no memory allocation, but the voice is prepared, set to waiting state, which means it has a event queue available for it. And then you go to this, what is it? This is kind of weird. Let me see. Then goes through all the voices, see if they are playing or released. Playing voices. Then if we still have voices, we are counting them here. We are processing them. So where is the setting? Where's the events being set up? Or maybe that is done separately. This is after all the events has been called. After the events has been processed. The event processing is here, I guess. Here's the process. Okay. So we clear the output buffer for every separate voice. No, this is the final buffer. Then we process all the events coming in for all the voices into the separate queues, so that we have prepared them as we have prepared a queue for every voice. Then we call the process audio this function here. So each voice I just kind of hand off to the thread pool for every separate voice, and in their own, so they all have their own buffers. And here's you calculating the setting up the buffers and kind of stuff, and then we mix all of them together. So in this mix function here, we could actually, if you're making our own processor, we could do more stuff here. For example, we could have some different effects, polyphonic effects. We can do VU meter checking. We can do all kinds of stuff, but so the thread pool is just calling into specific voices. And then later here, handling every single notes and stuff. As you can see, we are just queuing for we have a bunch of voices. That's an array of a predefined maximum array of voices. In this case, we have set it up to, where is it? Is set up as, where is it? I think we have max voices here. So in this case, we have 256 voices. So we have an array of 256 voices. And we set the state to waiting when we create them. You get a note on event. If you need to find a new voice, because when you're pressing a note, we want a new voice. If you're finding one of the three voices, set it state to waiting, because we are not calculating it, because it could be further into the buffer. If this is the kind of the buffer, maybe the voice is starting in the middle, but still have a voice. We still have a voice available from the start, so we can start to append events to it. And here we just note channel key and all that kind of stuff to it, so we have that part available. And then before we do anything, we clear the voice queue when we find start a new voice, and then start adding voices to it. If we are finding other note off, we do kind of opposite. We are just checking if it is active and stuff. If it is, where is it? Is targeted, that we check this port channel key and that kind of stuff to see to find all the voices which we should kill or stop, and then just enqueue this voice off event. Same thing with choke and not expression event. Here we go, same thing, but now we have, since we already have, we don't start find a new voice. That's only node on. We don't look for new voices here. We just look at existing voices and just add in expression events, parameter value events, and if it is global, it will be sent to everyone, and parameter modulation, transport, media, and everything. And this is all this stuff, comment and stuff here. If we are automatically converting from MIDI to note events, but I'm not really sure, so I don't use it. Sysec MIDI could have the same thing with Sysec MIDI too. Post-process events, what's that while doing? It's going to the voices, see if there are voices, which means if we have received a note on a buffer, and after the buffer is finished, if the voice is still waiting, it's something, some buggy things has been happening. Because it hasn't been, it hasn't started, because it's still waiting. So in case something goes wrong, we just kill it and get rid of it. If on same thing, if it's finished, which means that the envelope has completely died out, then we're just setting it off, so it's ready for the next. And we say this queue node ends. Node ends are events we are sending back to the host after the block is finished, to indicate that we don't need any more modulation events and stuff for the node. So we support polyphonic modulation. And what's here? Some support stuff. Where are we? We are in the end. Find free just goes through all the available voices. Look first, we see if we find any voice off, which means any notes or voices, which is not playing, which is not active, then we just return it. If not, we are looking through all the voices again. Not again, yes, yeah, we are actually doing it again. Maybe we should look here and save the first or last released voice, for example. But here we are doing it. Let's see. We're going through all the voices. We check if they are released, if they are in the last decaying phase. Then we look for the voice level, which means we actually ask the voice about its volume or the amplitude maybe, or the level, or the envelope, or the current playing level, and use the lowest one. So we always kill the most quiet voice. And after this one, we just check if we have actually found one. If it is actually more than 0, we start with -1. Then we kill the voice. We tell the host that this modulation for this voice is finished, so forget about it, and then we just start a new voice, just grabbing the index. So we have both. So you also have some voice stealing. This should probably have some if-def stuff around it. And finally, queue node end, we just add it to the node end queue, and the end of the buffer of the block, audio block, 256, 512, 64, or whatever samples. We just send every node end event for everything in the node end queue. We send a node end event. So we just tells the host. So the most interesting in the voice processor is this separation into separate queues for every voice, and then calling thread pool. Or here, what we actually do here is lots of combination of if-defs and what should I say, stages of status. So if you are compiling as if you are threaded processing, but if you're not, if processed, oh, we have something here. We have set the process to false here, and we check here if you actually did process something. So if you are processed, we are process threaded. We can also turn it off with an if-def. We call the clap thread pool. Else, if you are not using the clap thread pool, we have our own internal thread pool, which is a bit bare bones, or what should I call it, simplistic. We have this SAT thread pool here, which is actually not much big, not so very little. It just consists of a simple queue and a semaphore. And what we are doing, what is happening inside of it. We set everything to, we create threads for everyone up to gazillions of threads, 32, 256 or whatnot. And let me see if we have request exec for a number of voices. We are just calling enqueue them, wait semaphore, and we execute that task. We are just calling the same listener or a function for to call them as we did in the voice processing here. That's the same kind of stuff. Either we are calling it from the clap thread pool, which means the host is calling them, or we are calling it itself. And afterwards, we're just waiting. If not, my minus 6 minutes. Oh, and if there are no more tasks, we just see it. We are finished. So here we just exec task. We just call it. So everything is actually based on this blocking concurrent queue, which is actually blocking. That's this is blocking version. So it's a multi-consumer queue. Obviously blocking. Maybe there is. Let me see. Blocking concurrent. Isn't there any non-blocking? But you shouldn't be maybe. And some semaphore. Anyway, this is actually just first I copied something from I found some info about it on a forum somewhere here, I think, and just kind of replicated or kind of shaped it into using this already existing queues we have already using the Moody Camel queues. So it's very simple, but it works really well, except probably because of this blocking stuff. It is a little bit more jittering kind of stuff. It's not as smooth as the internal queue, probably because we are setting up a bunch of queues ourselves, which is fighting with the host queues. And as you can see, we don't do any. I try to do some scheduling priority setting, but I couldn't get it to really work. Probably because we have twice as many queues, or you have all the host queues and you hold our own. For example, let's see if we are running on my machine. I have 12 threads, or actually 6 cores, but with the hyper-threading, you can see what you can think of it as 12 threads available. And if we are also creating, in this case, 256 voices means we are actually setting up a thread pool with 256. No, we are not actually. Here we're setting up the num threads. I think we are actually setting up. It's been a while actually. Let us see. Let us see. Let's here. Is it in the constructor? Set process threaded, okay, and set init. Here is it. No, it's not. I'm not really sure actually. Let me see. I will have to. Oh no, I can't. Voice thread pool here. Set thread pool. Okay, we have a thread pool. Let's see if we can find it. Delete it. Okay, and num processors. Okay, we have a function here to get the num processors. Where this from sysinfo. So we are setting up. Let's say if the host probably reserves all the threads in the computer for its own internal use, and we are additionally adding just as many threads. So we have twice as many threads all the time, and they are fighting with the priority. So that's maybe probably why it's not as smooth as using a thread pool. But if the host does not support a thread pool, we can use our own. So we can have the thread pool extension actually working also in VST3, VST2, etc., etc. Which is nice because it gives us a nice boost for all formats without thinking about it. You can just set it to, in this case, let's see if there is some setup stuff. Here it's still in the process function plugin. In the constructor here, we set up everything. Let's see here. Here we said it's just set it to processed threaded, and that's it. And the processor is a voice processor. So because we're using a voice processor and we set it to threaded, everything is set up for us. We don't need to do anything else. But you can set it to interleaved or all the different stuff. So it's quite flexible. And we set up the editor size, and then we initialize it. Activate it. And we don't need this start stop processing, but everything is handled automatically in this plugin here. Has all the clap functionality. Here's the clap. The first thing here is always the clap extension, and then the function for the clap. So I think every single clap extension is handled, but a lot of them see is empty, as you can see. But they are here to just ready for you to override. What's else interesting? It's initializing, voice info. This is extension specific because not everything is set up automatically. You have some simplification stuff for register default synth extensions, which actually, as you can see, it registers first the normally default extensions, which are you need audio ports. And if you have GUI, we need the GUI extension, and we probably want parameters. And we probably need state, so we can save and load state in the host project file, for example. If you have a synth, we also need node ports. And if we are process threaded and we're using the clap thread pool, we also tell the host that we are using a thread pool. And we need to separate a voice info. Otherwise, we have to do it manually. For example, you can have, let's see this. We support, as you can see here, we can support all extensions. But we are not handling them properly, all of them, but we are supporting. Let's see, for example, here. You see audio ports activation can activate while processing. We just return false. For these things, you can support them, but not handle them properly, which is not very smart, I guess. But as much as possible, we have handled more or less everything here. or everything needed. So you can just, as you can see here, we just register the default synth extensions, plus a few more we want to support ourselves, like this in this case, parameter indication, which means the small colored triangles for every parameter, so you can control it with your MIDI controller. Or I mean, the remote controls and parameter indication, we can, for example, modulate the parameter and stuff, and we have it visible for us, and that's kind of nice. Both of these kind of works a little bit together. We are supporting the preset load extension because we also support the what is it called? Preset enumeration. What is it called? Let me see. Plugin clap factory. Preset discovery factory. Yeah, it goes through all the presets and tells the hosts about it. And if we support a preset load, we can load it in kind of real time, runtime. And we also will look at the track info, but we are not using it at the moment, but we are supporting it. We have a few simplification functionalities like clap note input, audio input, stereo audio input, and stereo audio output. Here's the voice processor is our own voice processor. This is, as you can see, it inherits from voice processor, which I looked at earlier. But we do have we override things where we are needed. For example, here we just call the previous one, plus we are doing our own master gain kind of stuff. So see, we could just scale it or final output buffer by a parameter. And we do some cheating with the logarithmic scaling stuff. So we just it cubed the input value. So we get kind of this kind of curve instead of linear. So we just we are lazy. We could do some decibel stuff here, of course, but well. The voice processor. Let's see what more. We just take care of some track info, and we have we know about this. There's some GUI stuff. It's very simple. As you can see, here's the entire processor, voice processor, or I mean our own voice processor. This is all of it. So we just override the constructor to let it know a few things, like if you want to keep track of some oversampling and buffer size stuff. The oversampling is not used at the moment. It's just set to 1, I think. But we set up a few things like this context, which is passed around instead of all this bunch of parameters, or I mean arguments. The processing, just do this gain. If we hadn't used this master gain kind of stuff, we could almost use the voice processor directly. With none of these. Let me see, what is this? This is a voice processor specific, so this could just as well be actually in the voice processor. We just set it up. This is okay. This is not really sure if it actually used the mode. That's why the comment is here, move to voice processor. So if you move this to the voice processor itself in the constructor here, we could get rid of the entire constructor almost, and the structure, and we always have this process. And if we hadn't needed any output scaling, we could actually just use the voice processor directly, and we could get rid of all of this. But now we have the possibility to do even per voice processing, for example. What's else interesting? That's not much more. Let's see this constructor on initialization, activation. As you can see, we're just letting the processor know, and we're returning the default implementation because maybe it do so. I don't remember. It's always safest to call this what's it called, this super class or this main class thing. Voice info, we just tell it we have a bunch of voices, and we are supporting overlapping notes, which means we can have multiple of the same playing notes. For example, C3, for example, P4, 5, and there's 5 voices with the C3, all of them separate. Nice for voice stacking, for example, when every voice is a little bit detuned, but still the same note. And that's what this flag is all about. Thread pool just calls directly into the processor and let the processor handle the thread string stuff. Remote controls, we're setting up one remote control page, oscillate OSC, and we're setting the 08 most. The voice, what should I call it? The oscillator setting for the synth. So we have automatically set up a page for my controller here, automatically. Loading, let's see what's that doing. It's just, okay, load preset from file is on the helper function. You just load it, and then we are, let's see, get clap host, we see use assert, we get there's a difference between the clap host and the host, as you can see here, because this clap host is needed. Why is that needed? Let me see. Oh, we have to tell it, tell the extension. Preset load, we tell the host that we actually loaded it or didn't load it on error, for example, if we didn't load it properly. Else we return okay. Track info is just printing out something for everything, just print, so we don't actually use it. We could maybe, for example, do some different settings if the plugin is in a send or return track, or if it is a normal audio track, for example. If it's an audio channel, we could do different things, and then, for example, we could print the track name so that we see if we are in a master channel or whatnot. For example, I'm just preparing it here. And the GUI stuff, we just here it's a little bit dirty. Again, we include a completely separate file for the GUI. Let me see what is actually, and this is a bit dirty. Or see, the coloring is because VS Code here doesn't really like me doing all of this kind of stuff. Like you see, for example, here, if def typically include guards, then just private directly into here. It doesn't like that part very much because it just directly pasted into here. So we don't really need the public part but we won't have private and public. So we don't need this, but this is my way of commenting kind of stuff. And timer, we don't use the clap. We will provide the timer using our own timer. And the timer is set up in the GUI. Every window can possibly, not automatically, but possibly set up its own timer. We're using the system timer, so we get actually, I think it's microsecond granularity or resolution, almost not a nanosecond, but the one that I think it's micro, 6 decimals places. It's quite, you see here. No, let's see, here's the timer stuff. This is the milliseconds, this is the microseconds, so next number would be nanoseconds. So it's on microseconds, so you have quite neat, nicely timer stuff, and everything else in the GUI is based on similar timers. So every window has its own timer, and this timer is kind of spread out to the twins, the automated. Also, every widget can kind of subscribe to a timer, and we are doing some housekeeping in the timer stuff. So at the moment, I think this is set to 50 times per second, 50 hertz. But let's see if I can find it. I think this is set up in my global config here. Bunch of config stuff here. Here is a bunch of magic numbers, magic constants, which I don't want to have spread around in the source file. And here's a bunch of options, turnable options. I try to comment everything, use vestige header, we send blah blah. But the number here is, let me see, it's window timer millisecond here. So it's 20 millisecond between the times, so it means 50 times per second. So 50 times a second goes to this, it gets a callback here. And then what we are doing, we are going to the voices and look at the state, and we set up we have a widget which kind of prints out the number of playing and released voices and kind of show some indicators. We go to every of them, set the states, then we set number of players, and also that's the only thing we are doing. Everything else is done automatically in this on editor listener timer plugin. We flush the part. Okay, this is from the host to the GUI. Okay, so we have queues both ways. Some of them handle in the pre and post processing part. So a lot of stuff is going on in the background here, so you don't have to care about it. You just hook into it and stuff. Here's the most ugly part is the GUI. It's, as you see, as I mentioned, it is directly included. We could have a separate file, of course, but then you have to do all the setters and getters and all that kind of stuff. Since I'm lazy, I don't care about it. So you have a bunch, no, not a bunch of, a few internal variables or set fields, something. Some people call them, I call them variables. Pointers to actually menus, and just one info text. What is this info text? What is this used? I am info text. What is it actually doing? Well, I'm just using it internally. Or for example, I print plugin format and OS name and versioning. So it's just for internally. I could actually have it in. But since I am sending setting a variable in the header, I mean a widget, and we don't know when the widget is being updated and drawn, and we don't want this to be go out of scope before. So if we put it kind of in here, so it's always available, so it doesn't fall out of scope kind of stuff. So it's kind of hack actually, but it works really well and no problem. There's no memory allocations. It just, or maybe we call it stack or whatever. But anyway, we don't care much. Setup editor is the function we are calling, and this setup function is the entire thing here, down to here actually. So you have setup editor and you have setup overlay. That's two different things in the GUI. There's actually at the moment there's 2 layers. I have been toying with the idea of having as many layers as you want. Just separate what is the background layer, what is the GUI widget layer, what is the foreground layer, for example. But at the moment we have just 2. The overlay is the I'll show you by compiling the demo again. And we just call the executable. Let's see here. For the background layer is the main layer, what you're being told to set up in the setup editor. Here you see we are finding the root widget. The root widget is the area where everything here inside the window is the root widget, because the windowing system knows just about one widget, the root widget. It doesn't know about anything inside it itself. It just sends all events to the root widget, and then the widget system is handling everything. And the same thing in the way back up from the GUI. So the root widget is the link kind of stuff between the editor and the window. So the editor doesn't have to know if there's actually a window up and running or anything. It just to have a way to tell whatever is on the other side something. So that's the root widget. So here we create it, and we are setting the windows. You have to tell the window that, oh, here we have a root window. And then this window, root widget, is a widget like everything else. And here we just set the background. We're not drawing the backgrounds and not drawing a border, which means because we are filling everything with other widget on top instead of it. And then the rest of the GUI is just appending stuff, because the widget system is made kind of a hierarchy of widget, which can have sub-widgets, and the widget acts both as a container for sub-widgets and also as a clipping rectangle, as a target kind of for mouse events. So the more events are not going into a widget or sub-widget until it's inside of a widget or a parent widget, for example. If we click inside a widget, then we are checking all the sub-widgets, then we're checking the sub-widgets, etc. downwards to find the kind of the topmost widget actually at that point. So a widget handles both the clip and also it's clipped around itself and all that kind of stuff. And maybe if you're drawing it, only the thing inside the widget is being updated and stuff. So it's handled as kind of a container for everything inside of it. And the root widget contains everything else. But on top of the root widget, the root widget is always to fill the entire area, the size, and if I resize this, or the root widget, that's the only thing that is getting told to resize itself. Then the root widget is telling its sub-widgets to kind of scale and reposition and do all this fluid stuff. Like here, for example, I have a bunch of here they're just resizing them here. On the right side here, they're resizing themselves. And also you can resize it while it's hard to do it while it's animating and stuff, but it's kind of hard to do. Oh, I don't have time. For example, or we also have some layouting stuff here. For example, these are all these knobs here are being they are set as stacked on the layout, so they are filling up as much as they can until they drop to the next side. So that's all handled by the event system from the root widget and downwards. And the same thing if I, for example, change something, then there's the event sent upwards into the hierarchy, and only the parts which is inside of the, for example, this one here now, if I move it, which means since it can be on top of everything, this kind of goes into and out to find which widgets is being told to potentially redraw itself and stuff. For example, if I change this part here is not being redrawn at all, but everything inside of this entire widget here is potentially redrawn, for example. So the widget itself is going mad, but what actually I was about to explain was the overlay. This widget here is put on the overlay, which means it doesn't affect anything on the bottom. If this will always be drawn on the top of everything else. You see, it's also that the animation is drawn via some timer callbacks, and because of that, we can also have, for example, this tweening stuff on top of the animation stuff. And everything is handled properly. And if you had modulation going or automation going on, these widgets here or knobs would be handled properly. So this green stuff here, green layer on top, is on the overlay. Actually, it is actually not. Now I forget when I remember it. It is actually just a widget on top of everything. That's so sorry, I was explaining completely wrong. This is on top of everything. What is on the root widget is this drop down menu here. You see everything goes darker when I click on it, because I have set it up. This is optional, of course, everything. The menu is on the overlay. And when I've set it up so that when I click on open out menu, everything on the root widget and downward will be darkened. It is a transparent black, but almost completely transparent layer on top of everything. And then the overlay will be drawn on top of it. That's why this part here is not darkened. So you can draw this on top of this, but it's still automating and to handle the colors. So only the menus at the moment. You could put whatever you want on it, and I am thinking about making it more flexible, like having multiple layers. You can have a background layer that never changes, so you could just split things to the background, or because at the moment, when I move, for example, over the part here, it is being redrawn from scratch every time I move it, but it doesn't use much CPU, as you can see down here. So I haven't really cared about it, but the idea is to have also a background layer which will never change. At least not in a real-time sense. Maybe when I resize the window, for example. This will never change, no matter what I'm doing. So I could just as well have it on a background layer. I just blit it to a screen every time I need to update that part. Or I could have multiple layers. One is coloring. This could be a separate layer, so it never is affected by anything else. Here, but this is this window stuff here is kind of a fakery. So that's still a little bit that's one of the newest stuff. That's why I haven't really. That's why I almost forgot about it, because both this tweening and this on the automation and this layering stuff can interact with each other, and it's a bit. And also this what to call it, modal stuff. I can't, as you can see, I can't edit anything else while this menu is on top. Except I can't even press escape at the moment. Right click inside of it to get rid of it. I don't know, I can select. But the idea is, of course, I have to click everywhere. Then it gets just remove it, and now I can actually resize the window. And you see there is some weirdness going on because of this stuff, because of resizing everything. So I'm not finished with, I'm not finalized it how it actually works. But I've still not decided properly how to do it, because I want to both have a fluid GUI like this, so I can resize things to have more space, and also to be scalable. Now it's kind of different. If I resize it kind of proportionally manually, it will be just resize it, but I could just drag it out, for example, or same thing this way. I've also been working on this dual layers. That's a new thing which stops at each other unless I press, I think it's Shift to swap them, or Alt to push the other one, or Control to go slow. So there's a lot of stuff and the edit stuff is not properly working because this doesn't support all characters at the moment. And this should be so-called 9-patch bitmaps, where you see this there's a faint line here and here, because this part is not stretched and this part is not stretched, but the middle part is stretched. But at the moment I don't really see the point in it. I will put it in here to be able to see it. So we could have bitmaps with corners and stuff, and then it could be this could automatically be stretched and all kinds of stuff. But as I can see, is everything works nice, fluidly, and no CPU use at all. This is actually OBS, most of it. Yeah, so it's starting to be quite, should I call it, functional. Here's also a bunch of stuff with text. I can just draw text to it and I forget about it, and just keeps track of the number of lines and that kind of stuff. Waveform use, but I don't have any waveforms into it. I can have vertical stacking and horizontal stacking here. This kind here, these are vertical. Everything is configured. You can configure everything, change everything, all the colors, all the sizes, even the painting. But this is just the default painting there, so you don't have to. Oh, this value, drag value, I mean. There's difference between all these different simplified layers or widgets. So you can already do quite a lot, and you don't. That's the nice part, is you just need this one single CPP file. We could compile some other things. For example, GUI-less plugins. You could have it automatically. Let's see what this is. I don't remember actually. Okay, compile this. Oh, this ID was actually a MIDI generator, all kinds of stuff. So I could hold Shift to make a red paint red ones, Control to paint blue one, green ones, and you can overlay them, of course, and you can have Alt to paint blue ones, and they are combined, so you could also do different stuff, and you can have a normal to highlight. So the idea is to have a kind of sequence of stuff, and this main idea here is to have this so-called game of life, or the Conway's game of life stuff going on. So everything things are touching. Right click is off, I think, isn't it? Control. What is Alt? Oh, right click is off, I think. Alt Shift to get rid of all the red. Control get rid of all green. Let's see. Alt to get rid of all, and then normal one to highlight. But as you can see, it just the grid stuff is being done at the moment, and some timing stuff here. Let's see what's on. And this interesting is that this is an entire thing. I think it also has the, let's see, this is the GUI. And this is the parameters. Also, that's also kind of interesting. The parameters and the widgets are also completely separated because I want to support no GUI and a GUI and different forms of GUI. So I have to connect them or everything manually. The idea is to have later have some kind of editor which is doing all of it for us. Let me see if it. Here's the is cell active, set cells. Let me update cell. Oh, here's the so-called Conway's game of life functionality. So it's cell set a cell dead or alive. So it actually works. Let's compile a clap plugin. Let's just try it. We'll format clap. We will call it, let's call it automata. No, we don't even need to because the plugin name is set here, so as a automata. So we call just a clap file and format clap. Let's see what it's actually doing. I wonder if it's actually working. Interesting. Let me see. Let's see. Let's have to. You see, this blue icon because this is a note that as we set it up as a note effect. Now it's blue, and we can drag it. Let's say drag it into an instrument here, and then we are setting up a synth after it. What happens if we set some reds and some greens and some blues and just press play? No, it doesn't update yet. Okay, so it doesn't update. Maybe it needs no notes because I don't remember anything about it actually. Let's draw Let's draw a few notes. See what's happening. No, it doesn't do anything at the moment. So it doesn't do it even update. But no, that's the idea. That's the idea is to later have some interesting meta thing. Automata. Sabotage is an interesting bit. That one is starting to be almost finished actually. Again, start bit big. We are stopping a lot. And you see after a few seconds you find a new one. This is an audio effect, so we are, let's say, starting aim and loop here. Let's see, then we drag this one on top of it, and you can see this is kind of interesting. If you start playing, there's a lot of probabilities, but still a lot of things to do. Can do a lot of stuff already with it, but I will work more on it later. All this is in Sabulum is a no GUI. Let's compile and it shows some interesting things because if you compile let's have a look. I think it doesn't have any GUI, which means no, wrong. Okay, we delete all them. We compile as an executable. I think if I remember correctly, this one doesn't have a GUI, which means it will set up a default GUI for us. So this is the default GUI if you don't do anything. This is not the best one, it's just sliders, everything is sliders. Why is this more dark and lighter? What? Why is this different color? I don't know actually. This is weird. Okay, maybe I could just maybe I can. I don't remember. It's been so very long. And it's stretch. This one is set to stretch vertically, horizontal. I mean. So this is how it looks if you don't setting up any GUI at all, and you can of course do your own everything here. And the hinting is not being done properly. A lot of stuff is not being done. What's is more interesting? So SA ports is a bit interesting. If I think this one is interesting because if we now start up, let's start it here. Let me see. I think if we can start /L, I think. No, it doesn't. No, again, wrong. Did I compile it? SA ports, compile. Oh, of course I didn't save it. I will have to save it. Save changes. So now we compile. This is interesting because let's see. Why is it working? Ugh. Didn't I add it? E2. No, I haven't added it at the moment. Why haven't I? Okay, I changed the hosts, the standalone host a little bit. Because I wanted I don't want to go into that at the moment. Again, exe, let's see if I can see it. Simple. Oh, I commented out a bunch of stuff here. Why haven't I? Oh, xlib, oh, that's completely different. Exe, why is this exe? Entry, everything is done by the entry. Okay, so I am in the process of redoing it. Where is this old backup? Because in theory I should be able to do some arguments and select the list out all the plugins inside of it and select one of them. But at the moment it's just, this is excellent, almost full host, clap host actually, and just starting up a window and with the host inside, plugin inside of it. But anyway, and this port here is kind of interesting actually. You can look into it. It's almost even simpler than other function. It has just one function and a bunch of includes. And we have this one is interesting. We define a no entry function, which means the default entry function is not being used. So we are adding our own. First, we register a bunch of plugins, and then we create one of the plugins depending on the index we get here. So you can have a bunch of plugins inside one file. So in this case, we are actually compiling all these plugins inside this same binary here. This is interesting in why, because we can compile it. Let's just test this. No GUI. So if I compile as a clap file now, we have I think, and I haven't tried it actually. If I compile as a no GUI, and a clap, and also it is not a debug, which means you can we can want to delete everything. Do it again. Interestingly, we now have a 400 kilobytes, then half a megabyte. Clap plugin, which contains, I mean, to see, interesting. To see, let us all these plugins inside of it. So, for example, we could have this stretch, which is actually this. What is it called? Is he called or a compositer, for example? Oh, we have to drag it here, and you can see. No, I thought you have to come. Here it is, it's all the plugins. But they are, of course, they don't have a GUI, but have all the parameter and stuff, and works just as everything else. Event horizon, and a bunch of plugins. So we can have, as you can see, a bunch of plugins inside one, and very small. So that works. It still works. I mean, is there anything else interesting? Test. Oh, this is working on some unit testing stuff. Some other stuff. A lot. This is more my internal. What should I call it? Internal tool or testing, or as you can see here. So I can very simply change plugins, so I don't have to do much on make files or CMake or build systems or do anything. I just compile and just need like a couple of arguments here. The build compile script itself is actually very simple. Let's try if I just type compiler, and you see here all the arguments. So input opens. They also have some functionality to set up some build number. It creates a file number with a lot. Let's say just try it. For example, if I try to compile this, let's call it automata.clap. I say automata, for example, and I want to do this build thing. And I could just what is it called? /b, or I mean -b. Let's say automata build.txt. Not care about this. But a build, for example. Let's see what's happening. And you see if everything goes right, we all know all of a sudden have a text file here. It has the number 1 in it because this is build 1. And now if you just build it again, you can go into it and see the build system is now 2 instead. And this is set up as a compile time marker inside the plugin, so I can use it, for example, to print the build version inside of it. And just compile to 3, 4, 5, for example, on the way to read so now it's 5. It's here. So I can do this for every separate plugin if you want. So that's the B or build thing stuff. Interesting. D is for debugging. F file type, or I mean format. G is GUI type. This type is no GUI. As you can see, you have no GUI, Wayland, Win32 is on that only works for Windows plugins, of course, and X11, which is for X11 for Linux. We have to add the W if to compile for Windows. In that case, we are actually using, let's call it no GUI for Windows only. And in this case, I'm going to delete everything just to try to assure we have done. In that case, you see that we have automatic clap here, but if we now examine it, you see this is a P832, a Windows executable, or DLL, I mean. And apart from that, everything still works the same way. But we are using MinGW, MINGW to compile, so I can compile the same thing for Windows and Linux just by adding this W here. And if I want an executable, I can, let's see, I haven't tried it for a while now, Win32 GUI. Oh, it took very short, automata clap, let's see again. No, it's an execute. And let's say we compile standalone version instead. It's much easier. Call it exe, typical for Windows, and we compile as an exe. And for Windows, it's buggy. Let's see. Lib means you here to insert main, so why not main? Exe, format exe win d, why not? Function main. Always some updates, what the F? Let's see, try something. Let's say demo then. Let's say format exe, what is it, GUI, exe, debug, it doesn't want to. Oh, I have some problem, so I need to do some updating, probably from the GUI stuff. Or is it actually Win32? Okay, I need to do some updating. W. Maybe it's a debug mod. No, I don't remember. Don't remember. We could actually make voice adding /v at the end. And then it prints out the actually command file. Command line to execute it. Compile it, I mean. Lib means you will CRT. Okay, there's some setup. I don't remember what it is. I can add some additional flags and a bunch of stuff. So it's very simple, but I have to do some probably some setup to make it work properly again. Oh. Anyway, so it's not documents is not good. I know. At the moment, you could the best thing you can do it is either ask in the YouTube comments or go to our Discord. You find it again on the, let's see it, Chrome. Let's see, github.com/shape. I say toolkit here. There's a link to our Discord. You could go there and ask whatever you want. Everything is, I'm often there, so I get notified quickly. Or me, email, or whatever. Just ask and I'll answer. So no problem. So what else? What's worth mentioning? Dependencies maybe, and libraries and stuff. You don't have to think about that at all, because everything is taken care of in the source. We have some an external directory here, which contains more or less everything you need, except for VST2. As you can see here, you see, for example, and you see I have this git ignore. You see I get to ignore everything because VST2 SDQ I can't distribute these files here. The same thing with VST3. Well, no, not I can, but I could distribute the XA SIMAR, whatever, which has a VST2 header, which should be possible to compile VST2 plugins, or the Vestige, but they are in GPL, and I don't want to force people to use GPL, so you have to do. I have a README file which says everything. Same thing with VST3. I have this travesty or VST3 SDK info, or there's no info here. I should add this here too. But I have. Do we need the plugin interfaces directory from VST3? So I should probably. Why is it not? That's stupid. There should be something here. Do you explain the same thing? I haven't done the VST3 for a long time. Same thing with probably with LV2 and that kind of stuff, but since LV2 in which people are using LV2 and stuff, you could do install sudo apt-get install LV2 dev on it, and then everything you need to LV2. Same with Lanspa dev on the Lanspa SDK probably, and with DSSI is DSI dev, and then you have everything. This and not Reaper. You have to do something to get this Reaper file. I think you have to call a function or something, do something in Reaper, then you get some plugin, some header files written in Reaper plugin or Reaper API, whatever. I don't remember anything. It's been a while. I can go help you with it if you need it, because I have started to add in a few additional stuff from the Reaper SDK. So you can do the Reaper specific plugins. Same thing with Ara. You need this Ara SDK from here. It's a burn file to get Ara plugins. Camera, what is that? This is the queuing stuff. Here are links again, links. Clap. I just compile the entirety of Clap inside of here, so the easiest just to, if you download the repository from the GitHub, it's already included because it's MIT. Nano SVG and Nano VG is for drawing on top of OpenGL. Signalsmith, I'm not only using this stretch thing here, which is already MIT, because it's a really nice pitch shifter. I haven't worked much with it, so it's not perfect. It's just a very simple drag into it, just to test for testing. SOGL is simple OpenGL loader, is for loading OpenGL extension stuff. Again, MIT, so I have included it. This works for Linux, Windows, and Mac. STB, I use a few STB files, image writer to write actually PNG and that kind of stuff very easily. Image for loading, PNG files specifically, and TrueType for using in NanoVG. WLAN, you have in that same thing, you have to call here. You have two functions. First, you have to install the WLAN SDK in some way. Probably, let's see again. Inst WLAN dev probably. No WLAN protocols or scanner or something like that. It's scanner. I see a WLAN scanner. We'll get the WLAN. Let's see. Get install WLAN LAN scanner probably, and then you just call these two functions here. And I don't want to compile for WLAN at the moment because I have to use this. I don't run WLAN myself. I have to run Western, I think, which is a WLAN GUI kind of stuff. Here's a way. This is a WLAN stuff. So I could run it here, but it's a messy thing at the moment, so I don't use it. I haven't tested it much more than I can actually open a window, or I mean a surface in WLAN, and get events in and out. But that's where I stopped. It got messy because I don't have any hosts supporting WLAN. I know Studio One supports WLAN, but I haven't tested it. And I thought about testing it for with just those floating windows in Bitwig, but I haven't tested it. Wrench is a scripting language, very simple, almost C-like scripting. Because I thought about making some script-ish plugin stuff, and XJSON is for actually reading and writing JSON. Only used for some testing plugins I made for some other people. MIDI is handling MIDI, MIDI files, MIDI player. MIDI files is for reading and writing all kinds of MIDI files. MIDI player is for actually streaming MIDI events into the voice processor or a synth. So you can actually play MIDI files. Also, again, made only for some testing plugins. Audio have a bunch of stuff, but all this is temporary or just harvested stuff from GitHub and all kinds of forum postings and all kinds of stuff. Mainly for my own testing, because I am not a DSP guy, so I kind of borrow all the DSP stuff from elsewhere. So I have a bunch of analysis stuff, Gertz analysis, beat detector, HAR analysis, RMS, and a bunch of other stuff, FFT, linear predictive, all kinds of stuff here, pitch tracker and stuff. Let's see, filters. That's gazillions of filters, all kinds of stuff. I usually this SVF filters, especially the. I think that's the best ones. I have different versions of a bunch of different filters types, which is nice to have available for test for maybe when you are experimenting and stuff. IO is for jack and jack audio at the moment only for standalones. Modulation, curved envelopes. This is what is it called, exponential. So you can have envelopes that goes and the tip is this curved envelopes. Exponential, I don't know what difference actually between them. I don't remember everything. And I also made a modulation matrix thing here, which actually works, but it's not maybe the most perfect way. But it's actually quite functional. There is process, has all kinds of processing as convolution. It's very minimal. It's just a brute force-ish convolution for reverbs and stuff. Delay is quite nice because I have both an interpolated delay with an effects or functions in the delay feedback loop, and also commented away at the moment, you have static delay. Delays is used for a lot of stuff. Magic kernel sharp, I'm not really sure what this one is. There is some interpolation for up or down sampling by 2. So I thought about experimenting with it for anti-aliasing and oversampling. And a resampler is for a quite nice one for resampling into different sample rates and stuff. Synthesis is the biggest one. It has a bunch of different synthesis, polyblep stuff, sinusoid, wavetable stuff. Wavetable is quite nice. And also have this different oscillators, a waveguide, resonator. And waveforms is actually anti-aliased waveforms, all kinds of different waveform types like polyblep, minblep, LTR is and LTR, DPW, PTR, all these are kind of anti-aliased waveform. A waveform, I mean, is something which converts from a phase 0 to not 1, but almost 1, from which going looping 0 to 1, a type phase or thing, and convert that to a waveform in different ways. Usually those are triangle waves, sawtooth, sawtooth, but with saw waveform you could make a square form, etc. And there are different forms like this. For example, this LTR, EPTR is quite nice actually. It's second and third, and polyblump for triangle waves usually. Polyblep or somewhere the angle is kind of, the slope is changing. And polyblep where you have this jump. Rockabye, I'm not really sure what it is saw form. A weird thing. I haven't experimented much with it. Sync, I haven't got it to work, but the spectrum looks nice, but I haven't really got it working. That table is for wavetable stuff. So it's a bunch of waveform generation things, and what is this? Oh, I thought about some simple audio stuff, code stuff for decibels and the normal stuff, and not very probably used much nowadays. And convert to hertz and samples and cherry some different stuff. Audio utils is for actually using mono to stereo buffers and mixing and adding and subtracting kind of stuff for simple buffering. What else interesting? Bass is all bass or maybe core stuff, things that are kind of below the plugin, and audio and the plugin stuff. Here's a bunch of the topmost here is for the framework itself, like this config stuff for all the configuration. We have the const, which have a bunch of constants, so you don't have to think much. You can use the constant like buttons, things like almost like enums, a lot of them, but I want to have everything in one place. Just some terminal codes for colors, Debug is for dragging in all debugging. We have a bunch of debugging stuff here too, like assert, breakpoints, call stack, analysis kind of stuff, crash handler, memory tracer. Observers is something special, but I'm not going into that at the moment. System is for making a cross-platform system kind of files. I can drag in, for example, just atomic, and then this should work for all the platforms. Like this lock here. It's dragging in, if you're Linux, you're dragging the Linux lock, and the Windows, if you're Windows lock. In Linux, we are using, let's see what we're using. Oh no, escape. We are using mutex, pthread mutex, and then within Windows, we are probably using critical section, but it is commented, so I don't use at the moment because I don't actually. Again, I believe the weird thing in this entire culture, there's not a single conscious lock anywhere except in one of the multi-thread queuing stuff, which is handled by internally in the queuing stuff. There's no locking, there's no mute access, there's no anything. There's a few atomics and there's a bunch of lock-free queues everywhere. So there's this, as you can see, I don't use locking at all. And there's still, of course, no crashing because the code, how it's all coded, means I don't need it. Paths is for dragging out the home path and desktop path, that kind of stuff. And all kinds of system-specific stuff here. And we have type is all for our internal data types. Like we have a bunch of lists. We don't use the STD standard library as little as possible because we don't want to be depending on it, but we have a few other stuff also, like this rectangle stuff. I have a bunch of rectangle stuff, like combined rectangles, some intersection testing. We have some stacks. We see just using lock-free queues thing. String is not being used, but I kind of prepared it. I want it to be based on the buffering stuff. I have this buffer here, static and dynamic buffer. So there's a bunch of data types kind of stuff. Array is a dynamic array. It's automatically resizing the array. And queue is a lock-free queuing, but I'm using actually some other queues. So there's a bunch of stuff here. And util is everything else. That contains a lot of stuff actually. Some very interesting, some awkward. Like this JIT, for example, is not actually just, it's actually a kind of what's it called, a code generator. You create runtime, you could create runnable machine code and just run it, like kind of just in time compilation stuff. I have both a VM virtual machine here, kind of virtual machine. It's very simple, but it works a bit. What's it called? Tail. What is it called? There is no go. If I do not want to go into it, and they have a compiler for it, and then I have also this JIT is more made for not for making a virtual machine, a bytecode, but for making assembly code directly. Call it. String utils, math utils, all kinds of utilities and stuff. Tokenizer. This tiny graph is actually this is weird. This is actually meant for a demo scene thing. This is a kind of a graph, execution graph for a 4 kilobyte intros. That was the initial I made it for. It's for like a 400 or 500K all in all, with all kinds of both the conditionals and expressions and calling and subroutines and everything inside all this. This is everything, all of it. So it's kind of weird, and better if you use it correctly, it can do interesting things. Tweening for a bunch of tweening stuff. It actually uses some easing, all kinds of easing functionalities. But setting up at an array of curves kind of stuff. Windowing is the same thing. We have all this hamming and all that kind of stuff. Branch is a script. Interpolation, it has all kinds of interpolation stuff. A bunch of stuff. From very simple to very advanced. Hermite interpolation, Catmull-Rom, all kinds of stuff. Isaac is an indirect shift, accumulate, add, and count. It's kind of a random, as you can see here, cryptographically secure pseudo-random number generator and stream cipher, which is still considered quite cryptographically secure. We could, in theory, use it actually for random numbers because it's really, really fast. And it hasn't been cracked yet, I think. You can use it, for example, if you come up with your own licensing thing, but I wouldn't advise it. I probably you would use some more known and tested stuff for that one. But if you come up with something Lua, just my very little test for Lua, you can just include this Lua here and just compile, and then the Lua just works. So it's a bunch of stuff. Neural for neural networking, but it's not advanced, it's just very primitive. But if you want to test DMC, it's interesting. It's Markov compression is an what's it call it? Arithmetic coding, predictive arithmetic coding. So it's a kind of a compression, and it compresses actually really well. I could almost, if I prepare data correctly, touch almost like PNG. So I was thinking about creating my own file format for using the plugins. Arguments for argument parsing, so it's all kinds of stuff here. Things that are not necessarily plugin related, but could be interesting to have available in plugins. That's the idea. What's interesting here? Log files, printing, registry. Registry is not a Windows registry, but my own kind of global place to register stuff. To have them always available and kind of control the creation and deletion of stuff. stdlib is my idea to kind of replace the std. I could define no stdlib and then replace all this. But it's, as again, it's not there yet. Test unit testing. So that's kind of what is included. A plugin has, I got this so much. It still works, and it's been a while since I coded everything, so but I'm planning to get back to it. I kind of started shaping it properly again to, which I'm not really sure. I go through it and polish it and make it better. That's the idea. Making the windows work probably. I know actually that more or less everything except the GUI works on Mac too, because I know that someone has been compiling especially the clap variation. No GUI variable on Mac, and it has I also got some reports that the GUI stuff almost worked using some metal variation of NanoVG, I think. I don't remember. It's been a while since I heard about it. But it actually shouldn't be too difficult actually to get it working on Mac, since I don't have a Mac, and since Apple doesn't want me to compile Mac stuff without a Mac, so I'm not going to look at it myself. But it should be, at least in theory, possible. Also, I started to experiment with CMake, even though I don't use it myself. I said I just looked at some online documentation and tried to set up some CMake stuff here and some CMake preset stuff. I have no idea if it as you can see, it compiles. Actually, I compile as much as I can probably. Let me see if I set things up properly here. I think I actually can set it up to build and run and debug. Let me see. Let's take the demo thing here and just press build. Oh, it's compiling a lot, and see I think the build here is filling up with CMake stuff now. As you can see, bunch of stuff here, but oh, it fucks up my directory settings. But okay, with arrow, and I can just press run, I think. And here it is, compiled by CMake. And I can probably run, where's the debug? This one, launch the debugger. And now I can probably, what is this? Stop this. So I can use at least a little bit. But it messed with my directory structures. It created this build directory, which I don't want. So I'm not using it myself, but as soon as it worked, I could, in theory, add in some breakpoints and just run the debugger from here. But that's not in early stage, but barely working. So there you have it. That's the current state. I tried to use including tools. The tools is kind of interesting too. Let's say because again, since I don't want to use make files or build systems at all, I want to just compile a CPP file and that's it. I include all data directly as not as you can see here. For example, all the images, like for example, this logo.svg. It is actually this SVG file. Where is it? I don't have it here. This one. Can I double click it? No, I can't. But I compile it as you can see here as the array of bytes. And this one, all this data included, the fonts and the bitmaps is compiled with this one file, and it has this one on top. So as you can see, it's C files, but you can run it from the compile line directly. For example, tools here, you can just run in to H, for example, and say here, let's see what it says. As you can see here, hello world, it prints here. And it just prints. Because this is using TCC, tiny C compiler. Again, just a sudo apt install, I think it's called tiny C. No, Control C, TCC, just install TCC. And then you can run a C as a script. Same thing, I haven't started yet, because I haven't not really sure about the argument parsing. Do the same thing with the compile script, but I'm not using. And finally, I have this to do this in C LV2. We have to do this manifest.ttt nonsense. So I am actually loading the plugin and calling into a function I've exported inside the binary to dump the manifest and then exit. So this is a little file to do this for me. So I could add it in the compile script, but I'm not using it because I will drop LV2 completely. But interestingly, it's a TCC file, so you don't have to compile it or anything. You just run it. Again, it falls nicely into my no build system thing, because we have everything, the entire build system in this compile script here. This is with some defaults, a bunch of default settings, some printing the arguments, and then here it's actually parsing the arguments and then handling the different arguments different ways. For example, the build counting stuff and the format, and setting just what should I call it, variables. And then finally, after you've gone through all of them, you just call the arguments here. This CC is just, of course, G++, unless you compile with W, which is W, which means we set the CC to be, where is it, window, we set the CC to be this GW thing. So that's it. That's the kind of how it, maybe I should make some better ones. Licensing is MIT, so you can do whatever you want with it. But of course, mentioning it somewhere would be nice, of course. But you don't have to. You can just look at it. You can rewrite stuff. You can do whatever you want. Also set up Doxygen setup here. It's a bunch, as I mentioned, as you see here. All these are, we call it example plugins or test plugins. In all, you have BND files, Node plugins, note effects, synthesizers, effects, you have standalone executables, you have kind of everything. Windows. And Windows, of course, is not working properly yet because I don't care much. But if other people care, I would look into it. So let's see. Maybe I'll get back to it soon, unless not. I don't know. We will see. We'll see. I'm at the moment I am not busy with it. I'm working on a new album, so I'm not sure if this is my main priority. But if other people are interested, I will jump back to it again. So let's see. This is enough. This is just me rambling and talking nonsense, probably. So let's say that's it. Bye.